All right, now we're going to look at understanding and solving basic inequalities. So why don't you take a few moments to copy down, or press pause, copy down this problem, and actually see if you could think through it on your own and try and figure out when this tree will be taller than 77 feet. Then press play when you're ready to move on. Okay, so we have a tree that grows 3 feet each year, and it was planted when it was 2 feet tall. So we want to know, when will this tree be taller than 77 feet? Now this is a very similar and familiar situation. Okay, we just have a tree growing. Okay, but now we don't want to know, like, when is it a certain height? We want to know, when is it taller than a certain height? And that's what an inequality is. Inequalities aren't when things are equal to each other. They're when things are more than or less than, taller or shorter. Okay, that sort of thing. Now the nice thing is, we kind of think through these problems the same exact way. Okay, so I don't know if you thought through it. If you did, you get that it's after 25 years. This tree will be taller than 77 feet, which if you got that, that's great. You could think through these intuitively. Now let's try and work through this a little bit more algebraically and try and understand all the bits and pieces of what we want to do. Okay, so I know none of you probably did this, but 3x plus 2 is the expression. Okay, we have a tree that's 2 feet tall and it was planted and it grows 3 feet each year. This is something we're very good at doing, writing a quick, simple rule for a situation. Now we want to know, when is this tree taller than 77 feet? Okay, and that's what this greater than 77 is. We want to know, when is this height going to be taller than 77 feet? So the very first thing we want to do, and I'm sure this is what you did, is we want to find, well, when is this tree? When is it 77 feet tall? Okay, so we want to know when it's something taller than 77 feet. Well, let's just first answer, when is it 77 feet? Okay, so there's a few ways you could do this. You could kind of play with this equation, try and just do guess and check to figure out when this equation is going to be 77. Or we could just say, when will this tree equal 77 feet? Okay, we solve this by subtracting 2 from both sides, and we get 3x equals 75. And we get x equals 25. Okay, so we get, after 25, or in 25 years, the tree is 77 feet tall. Okay, that's great. Okay, but we don't want to know when is it 77 feet. We want to know, when is it taller than 77 feet. So basically, we understand that this tree is growing. Okay, so we kind of, in our minds, make a little table of what's going on. Okay, in 25 years, the tree is 77 feet. So in 26 years, if it's growing 3 feet, it's going to be 80 feet. In 27 years, it's going to be 83 feet. That means back in year 24, it was 74 feet. Okay, so this is just what we think. We could write it down if we want to help us think about what's going on. Okay, in 25 years, it was 77 feet, which is great. Okay, but again, we don't want to know, when is it 77 feet. We want to know, when is it taller. Well, we know the tree grows 3 feet each year. So in year 26, it's 80 feet. 27, it's 83 feet, and so on. And it continues to grow. So basically, what this means is, this tree is taller than taller than 75 feet after 25 years. So we would say, after 25 years, the tree is taller than 77 feet. Okay, and that's really it. Okay, we see in the 26 year it was 80 feet, 27 it was 83. So after the 25 years, because it takes 25 years for it to be 77 feet, the tree is taller than 77 feet. Okay, now we just want to finish up this problem. We wrote our answer as a sentence, which is very good, and we want to write it more algebraically. So after 25 years means we want our x, the number of years, to be greater than 25. Okay, this means after 25 years, and let's put this on a number line. Because whenever we're making an inequality, this might be something you want to press pause and write down. Whenever we're doing an inequality, or whenever we're solving an inequality, you need an inequality in your answer, and you need a number line. So you need an inequality and a number line whenever you're solving these. In our number line, we're just going to kind of center around the point 25. So now we're just graphing x is greater than 25. Okay, we know this means we have an open circle at 25 because that's what our boundary. This is what our this is when it equals 77 feet. So you have 25, and we know after 25 years, so we shade to the right. This is the inequality x is greater than 25. So again, this problem was pretty intuitive to start, but we wanted to go through and think about all the steps algebraically. So we found, when is it 77 feet? That's after 25 years. Okay, so then we kind of thought, well, this tree is growing. So in 25 years, it's 77 feet. In 26, it's 80. In 27, it's 83. We just made this little table to help us understand and organize our thoughts for the pattern that this tree follows. So now we just want to know, when is it taller than 77 feet? Well, that's after 25 years. And we see that it's shorter than 77 feet before 25 years. Okay, then we just write our sentence. After 25 years, the tree is taller than 77 feet. We write our inequality. This is x is greater than 25. That's just smudged, not anything important. X is greater than 25, and we just make this number line. That means 25 is where we start on our number line, because we're talking about all the numbers after. Okay, good. Let's try another one. Okay, there are 52 cookies originally in a pack. Okay, you eat 2 cookies each day. When will there be more than 10 cookies left in the pack? So again, you could press pause, copy this down. You could try and think through it on your own, and then press play when you're ready to go through it more algebraically. Okay, so if you did try and think through this and solve it, you would find that before 21 days, everything up until 21 days, there's going to be more than 10 cookies left in the pack. So let's try and follow this same process. Okay, so our simple equation or expression is 52 minus 2x. We have 52 cookies originally in the pack, and we eat, so we subtract 2 cookies every day. If you wrote this down, great. If you didn't, well, let's just try and follow along with how we do it algebraically now. So we have 52 minus 2x. We want to know, when is there going to be more than 10 cookies left in the pack? Yeah, we could probably solve a lot of these problems intuitively, but the reason why we want to start writing our inequalities is because when we get to problems that aren't word problems and we can't solve intuitively, we have to understand how to work through with the more algebraic examples. So again, we want to first figure out is, when are there 10 cookies left? Okay. So this is always, it's like before we want to know when the tree was 77 feet. We want to know now, when will there be exactly 10 cookies left? Okay, so however you solved it, by guessing and checking or by solving this equation, is fine. But we're going to get in the habit of writing out the equation and then solving. We want to know, when will there be exactly 10 cookies left? So we solve this equation. So I'm going to subtract 52 from both sides, and I get 2x equals negative 42. Now I divide by negative 2, and I get x equals 21. So we find that after 21 days, there are exactly 10 cookies left. Now, we make our little table to understand what's going on. Okay, so we have 21 days, there are 10 cookies left. What about 22 days? Okay, what about 20 days? Well, if we're eating 2 cookies each day, if there's 10 cookies left after 21 days, we're going to eat 2 the next day, and this is going to be 8. Okay, then 23 is going to be 6, and 24 is going to be 4 cookies left. That means back on day 20, there were 12 cookies left. Okay, again, we just have 21 days, there's 10 cookies, and we know we eat 2 cookies each day. So we're just subtracting 2 cookies, because we want to make this table to understand what's going on. When will there be more than 10 cookies? Well, we notice kind of before day 21 is when we have the more cookies that we want in our problem. So before 21 days, there will be more than 10 cookies left. And now let's write our inequality. Well, before 21 days is x is less than 21, because x is the number of days, and we make our number line, and we just center it around the point 21. So here's 21. And we have all the days before 21 is when we have more than 10 cookies left in the pack. Okay, so as you can see, it's a very simple algebraic process. Okay, we find when are there 10 cookies left, and if you did it intuitively, that's actually what you found first. Then we try and understand what this pattern is. So we make ourselves a little table. We start with when we have exactly 10 cookies left, so 21 days we have 10 cookies, and we understand the pattern. What is it after 22, after 23, at 20, at 19? Okay, then we ask ourselves, well, which do we want? Do we want before the 21 days or after the 21 days? We want more than 10 cookies, so we look at where are there more than 10 cookies? Well, that's before 21 days. And then our answer, again, is our inequality and our number line. Okay, good. Now let's look at what if we're just given an algebraic example. Again, we're still saying simple at first so we can understand the process. But what if we're just given this? 2x plus 7 is less than 101. So we want to try and understand what to do here. Well, just because we don't have a situation, one, doesn't mean we can't think of this problem as a situation. Two, it doesn't mean we don't change our steps. Okay, so we're still following that same technique. Okay, we want to figure out when will 2x plus 7 equal 101? Because pretend like this is a tree. We planted a tree when it was 7 feet tall. It grows 2 feet each year. We want to know when is it shorter than 101 feet. Okay, simple equations can represent simple situations. So the very first thing we do is we find what's called our boundary point. Okay, this is when does it equal our number, and in this case it's 101. Okay, so the first thing we do is when does this equal 101? So we find our boundary point. So we do 2x plus 7 equals 101. When will this tree be 101 feet tall? So we solve it. We subtract 7 from both sides. We have 2x equals 94. We divide by 2 and we get x equals 47. Okay, so we found that after 47 years, the tree is 101 feet tall. So what this means is our boundary point is 47. Now the reason why we call this the boundary point is because this is when it's going to equal 101. So this is where that number line is split. Okay, maybe the tree's shorter up until 47 and taller after 47. Okay, this 47 is when that inequality changes. So what we did here was we thought of our little table. We made a little table to help us understand what was going on around the point 47. So after 47 years, it's 101 feet tall. So 46 years. So all we do here is we want to figure out how tall is the tree, or what's the expression, 2x plus 7, when x is 46. So let's just write it out algebraically. We do 2 times 46 plus 7. And this equals 99. Okay, that makes sense because it's growing 2 feet each year. And the same thing over here. All we're doing is saying how tall is the tree after 48 years. We do 2 times 48 plus 7, and this equals 103. Okay, and that makes sense because it's growing 2 feet. So this is helping us understand kind of this pattern. So 2x plus 7, we want to know when is this going to be less than 101? Well, it's going to be less than 101 before 47. Okay, so we just think before 47, it's less than the 101, and this table helped us figure that out. So this second thing that we did was the tested points, and we did this by making a quick table. Okay, and that's what we did here. 46, it's 99. 48, it's 103. So now we plot our boundary point on our number line. shade the appropriate side, and write our inequality. Okay, this is just 3 is basically saying answer the question. So we center our number line around our boundary point. So that's 47. We know that it's less than 101 before, because we found that before in our table, and we want less than, so we go to the left. So we're shading in our appropriate region. So we saw after 46 years, it's 99 feet tall. After 45 years, it's going to be 97, and so on beforehand. And let's write our inequality. This is x is less than 47, because we have before 47 years, it's going to be shorter than 101 feet tall. And this is our answer. Okay, one more thing together before you try these on your own. Hopefully we're thinking this is easy. So we want to know, how would the solution change if we had 2x plus 7 is less than or equal to 101. Now, as we see here, everything in this problem is the same, except now we have this or equals to. So this or equals to means the boundary point is part of the solution. Okay, that means we also care when this tree is 101 feet tall. So, and because it's part of the solution, we would fill in the circle. We'd have a full circle like that on our number line and include it in the inequality. Okay, so the whole problem stays the same. We have the same number line because the problem didn't change, just we're including the boundary point in our answer. So this or equals to means, well, we also care about when the tree is exactly 101 feet tall. So that's when it equals 47. So we just shade this in. That or equals to means we shade this in, and we still have the numbers before 47. And our answer is x is less than or equal to 47. So we also include an answer. Okay, and that's it. So just because we see this or equals to doesn't mean we change anything, except we shade in this point at the end and include it in our final answer. Okay, so why don't you try 2 on your own. Follow the same steps. So we have 3x plus 8 is greater than or equal to 38. And 103 minus 4x is less than 11. So follow those same steps. Remember, you found the boundary point. You test points by making a quick little table, and then you just organize your answer and your thoughts on your number line and as your inequality. Then press play when you're ready to go over it. Okay, so our first thing we do is we find our boundary point. So we want to know, when will 3x plus 8 equal 38? So we solve this. 3x equals 30 by subtracting 8 from both sides. Now we divide by 3 and we get x equals 10. So our boundary point is x equals 10. So now we test points by making our little table. So we have 10, it is 38. What is it at 11? What is it at 9? Okay, that's all we need. We could go to 12, we could go to 13, you could go to 1,000,000. But if we just do one before and one after, we understand the pattern. Okay, so 9, we want to know what is 3x plus 8 when x equals 9. So we do 3 times 9 plus 8, and we get 35. If you thought of it more intuitively, this makes sense as well, because we're like growing 3 feet each year. So it's 3 feet shorter. Now it's going to be 3 feet taller, but let's just do it algebraically. We want to know how tall, or what is 3x plus 8 when x is 11. So we do 3 times 11 plus 8, and this equals 41. Okay, again, that makes sense intuitively because it's growing 3 feet each year. So we want to know, when is it taller than 38, or when is it greater than 38? That's this way. So we make our number line. Okay, we center it around our boundary point. Now we notice the original inequality was or equals to. Okay, so we also care about this 38. And this is wrong. Sorry. Let's try that again. Our boundary point is 10, so we center it around 10, 8, 9, 10, 11, 12. This is better. Please don't make that same mistake I did ever again. X equals 10. This is our boundary point. We shade this in because we care about our x's in our number lines. And we have greater than going off to the right. And this is x is greater than or equal to 10. Again, it's or equals to in the original problem. The point shaded in, so it's or equals to in our answer. Okay, this one. First thing is find our boundary points. You do 103 minus 4x. When will this equal 11? Okay, we subtract 103 from both sides. We get negative 4x equals negative 92. We divide and we get x equals 23. Okay, so maybe this means after 23 days, there's 11 pieces of candy left in the bag. So we test our points by making a table. When x is 23, we get the 11 that we want it to be equal to for our boundary point. So what about a 22? What about a 24? So you do 103 minus 4 times 22, and this equals 15. Same thing over here. What about 24? So we do 103 minus 4 times 24, and this equals 7. So we want to know, when is this going to be less than 11? Less than 11 is this way, after 23. So now we organize our answer. We're not going to make the same mistake as before. We put our x's on our number line, 21, 22, 23, 24, and 25. Okay, we keep this as an open circle because it's not or equals to. And we shade to the right because that's what our table from part 2 told us to do. And we write our inequality, x is greater than 23. So when x is greater than 23, 103 minus 4x is less than 11. After 23 days, there's going to be less than 11 pieces of candy left in the bag. Okay, great. So if you need examples still, refer to the textbook or our packet really, or some of the other online resources.